dalszy ciąg debaty między Basem Lansdorpem a pracownikami MIT na temat
So I think one thing that I want to point out, and that was an excellent presentation, we think that Paragon study is some great work, and anyone here who hasn't read it should really go read it. Excellent coverage of what needs to be done to get to Mars, possible ways to do it, a lot of good research and development going into that. So I think, Sydney, you want to start out?
Okay. So there was the discussion that the Mars One plan is very much in the pre-phase A phase, and the concepts are still being developed. So one of the fundamental questions, and over the last 4 years, the Mars One plan has been sold very clearly as a mission to send people for crew to the surface of Mars for $6 billion first crew, and first crew landing there 2023 to 2027, some schedule slips. But the concepts are still being developed. So if the concept has not been finalized, how can you claim feasibility for your mission? You need a concept to do the analysis, to look at the cost, schedule, scope, because as I mentioned before, projects are holistic. You have to look at them holistically. You have to address each of those things. If any of them fails, then your project is at risk of not going through.
Shall we
just
alterate right away? I think that's a lot easier.
Would you like to?
Should we just make it a conversation?
Yeah. No? Fine. Okay, so, yes. No.
So I totally agree, and what Mars One has done in the beginning of our program is we've made a mission design, a very elementary mission design, and we've visited aerospace companies like Paragon and many others, and we've discussed the costs and the mass budgets and the timelines with those companies, and with their feedback we've come up with the numbers that we present. New reports like the one that Paragon released, where the mass of our life support system goes up significantly, will need to be taken into account in our plan. Our initial mass estimate was a lot lower for the life support system, so that needs to be taken into account. What we will do, we're not going to do that in the current design of the mission. What we want to do first is have a study performed on the landed mass, because that's basically the building block of the outpost. At this moment, Mars One unfortunately can't afford the study by Lockheed Martin on the landed mass, and I think that is the main challenge for Mars One right now. It's to secure the funding for having those studies performed. But don't forget that it's a crazy enough project that also positive surprises can happen. So it is so ambitious, and I think crazy is the right word, that we might actually get a phone call from a billionaire who says, I want to make this happen, I want the first city on Mars to be called Gatesville or Slim City. And that will change everything. Hey? Imagine Mars One having $6 billion in the bank. Suddenly all the big aerospace companies that have some kind of capability of landing systems on Mars will be calling us and making us offers for a reliable transportation system with a guaranteed investment from us, or us as a guaranteed customer for 10 or 15 or however many rockets we need. And so those kinds of things can change everything. So if we need to muddle along for 25 years, then obviously the cost will be higher. If we get a positive surprise like that, then I actually do believe that the cost might be lower. Not by much, but maybe by a little. And we will continue to update our plan with the data that we get. But when we presented our timeline and the $6 billion cost, that was the best knowledge that we had in discussion with the aerospace companies that we talked with.
So I guess then the question would be, you've gotten the first couple reports back, we've done one report, we've talked about several challenges today. maybe this is a two-part question. Given what you know now, based on what has been presented, what Paragon has done, what other studies have been done, what would you change about the plan? And if I had $6 billion, which I'm sorry I don't, if I gave it to you right now, what would you do with it?
I think that it's very important that we don't start changing our plan until we do have the landed mass capabilities, because it will be a big guess. And we are and we're very convinced that a 2.5 metric ton payload is very feasible. And let's not forget that Curiosity rover landed at 2 kilometers altitude. For practical reasons, we will land at -4 kilometers altitude.
Curiosity landed at -4. Sorry, the Curiosity rover landed at -4. That's not correct.
The Phoenix landed at -4.
The Curiosity Gill crater is -4.4 kilometers.
Well, let's check it out.
Okay.
So, and you asked, your second question was? Oh yeah, if I had 6 billion. So the first thing I would do is either to hire a very extensive technical project management team that can investigate all the things that we need, make a good mission design, look at all the interfaces that there are, and then have all those studies performed such that we know exactly what our mission plan will look like. Is it -4?
4,400 meters below Martian sea level.
Good to know. Thank you. One thing that I would like to say. So we have a very interesting business case compared to the space agencies. I was really shocked actually that our candidates think that they will be followed 24/7. Please no. What I think is that our candidates will be very proud of what they do, and they will want to share a lot of things like they're doing here and like they're doing on schools. But they are always in control of what will be going to Earth, because they are in control, right? We can't send the Marines if they don't do what we tell them. So, but on the business case, I have met with many investors, and all of them see the business case. They don't worry at all about the business case, and they don't even worry about the mission becoming twice or 3 times more expensive. What our investors worry about is 2 things. Technical risks. So what, for example, there's the 10%, 5 or 10% chance that a rocket explodes. What if the first unmanned mission fails? Fortunately, we can ensure the first unmanned mission because it's a copy of the inside mission. So it might be very feasible that we ensure it and that we can try again. But the other thing that they're very worried about is that someone else beats us to it. But they're not at all worried about the business case. So what I present to investors is that just the media side of Mars One can yield 8 times what the Olympic Games are worth, which is about $36 billion from today until the first humans on Mars. So that's a good return on your investment. Doesn't matter if it's $6 or $12 billion investment. And then there's the intellectual property development and all the other things. And one of a space funeral company approached us and said, if you're going to Mars, we want our customers, they sent small amounts of ashes on missions to orbit or even to suborbital. We want our customers to be part of that. When I came up with the business case for Mars One, I wasn't considering the funeral business. So there's so many new business cases that come along, and investors are really into that. So they've literally said to me, the cost is not so important to us. It's about, can you guarantee that this will happen?
You need stairs.
Should use solar panels. We can share.
Okay, so you mentioned that you thought that our study found the Mars 1 mission plan to be feasible. However, the big takeaway from our study is that based on the Mars 1 mission plan, as claimed on the website and as you have advertised on several occasions, is fundamentally unsustainable because the cost grows over time as you increase the number of people on the surface of Mars. You've also said that all the arguments you've said so far were regarding the 6 billion figure number, right? But when you launch people, if you do that is, to Mars, one way, you have to resupply them every 26 months. And that incurs more and more cost for the rest of their life. So how do you make the business case for people who are investing in this that the cost that you're incurring by making this decision that they need to be resupplied every 26 months for the rest of their lives, which is several $billion dollars, that just doesn't close when we look at this. And this further doesn't close when you add more and more people.
And on top of that, you mentioned the technical risk. That's kind of, I guess, curious that an 8-time return on investment for a risk that's something that has very, very many myriad challenges ahead of it and incurs a cost obligation unless you're willing to stop resupplying the colonists, which I assume we aren't, for a very long time. I'm curious just how that all closes.
Hey, and Bas, I'm not going to pick on you, but I've asked some of the same questions, and you've talked to me about the business model side of it and how it pays off. And it took me a long time to get my head wrapped around it, but I think you should talk about that. And for me, I'll just tell you, the takeaway is, I'm going to tell you what my opinion. You don't have to launch a crew every 2 years. Sorry to the candidates for this mission to be successful. If it's every 4 years and then every other time in between is a supply mission, what I understand now, that's not going to change the business model, the side of where the funding's coming from. So I think that needs to get explained a little better because it took me a long time to understand it.
Yeah, that's right. So we hope to send humans every 2 years, and we do still believe that is feasible. But if we can't, for whatever reason, it could also be that when the first crew goes, the hardware for the second crew goes with them. But if one of the systems breaks in such a way that they can't fix it, then the second crew will go 2 years later. That's already part of our plan. So if we can't send the crew for a different reason, for example financial reasons, that's also something that we can accommodate. So you had 2 other questions. One about the return on the investment. Actually, the return on the investment is much higher than 8 if you invest early and much lower than 8 when you invest late. It's always like that. So the first investor that comes on board will finance, we're currently looking for $15 million US, will finance the build-up of a very good team, so a very big expansion of the team that is actually capable of starting to roll out this program in a lot more detail. And financing all the studies that we need to do, and building a simulation outpost where we need to start training the crews. But after that is all done, and there are these very detailed reports from the aerospace companies that we're talking to, then the risk will go down, because there's more known about the project. So the next time, the investors will pay more per share, so they will get a lower return on the investment than the first ones coming in. That's how it always works with companies throughout their development. What's very important is that something that's not a current existing technology, but that's a very important part of the Mars 1 plan in the long term, that we need to start producing things on Mars locally. So one of the things that I would really like to do as soon as possible is to write out a request for proposals from all kinds of I shouldn't say institutes, entities, so it could be schools, university teams, whatever. We want to see proposals for how do you build a habitat with local materials. I really recommend to you, one of the coolest videos I've ever seen on the internet is, if you Google glass sintering, there's an artist that 3D prints sand. It's so cool. So I don't know if we can build a system like that on Mars in 10 years, but there's no real reason why we couldn't. So if you can start building your habitat, so your habitable volumes on Mars, and maybe send a bladder to make them airtight from Earth, that will save a lot of mass already. And in that way, we need to start implementing smart solutions. And there's carbon molecules on Mars, and there's hydrogen molecules on Mars. So in principle, if we have energy, we can make plastics. And so all kinds of things are possible, but I don't think we need them for the first 2 crews, but I do completely agree with you guys that we need to have some kind of local production method to sustain a group of people that is larger than that. But do you think that is technology that we cannot develop in 20 years?
Well, I think, again, it depends on the funding and the schedule, so those two things are linked. So NASA, actually the challenge you just described, NASA has that challenge ongoing right now. There's a 3D printed habitat challenge exploring how to use Martian regolith. So I completely agree. These are the kinds of things, and this is in general as far as how to move the Mars exploration, Mars colonization, Mars settlement plan forward. These are the kind of problems that absolutely need to be solved. And maybe it'll work in 20 years. Maybe there'll be some breakthrough tomorrow and someone's already figured something out, we just don't know about it yet. But there's all this uncertainty and there's a lot of cost going into developing that capability. So I guess one question that I have that I think has been a part of this whole discussion and a part, I think, since our study came out, is a question of really the difference between a new technology and a new system. Because that's something where I think maybe there's some miscommunication. So you said that a new technology or we don't need new technologies, and I'm paraphrasing a little bit, because the processes are understood. There's no fundamental reason that these things can't be done, right? So then the question would be, when Goddard fired a liquid rocket in 1926, why didn't we immediately go to the moon? Why didn't we immediately go to Pluto? When Sir George Cayley described the physics of flight in the early 1800s, why did it take 100 years for the Wright brothers to do it? So I think that's, I guess we find the cost element to be not just until understanding the process, but making a process into a usable, feasible system. So I'm curious, what are your thoughts on the difference between a technology and a system?
Maybe from the life support system, I can talk about that a little bit. So your analogy about rocket development, where we are in the development of life support systems, of those core technologies that do the water recycling, that do the air revitalization, we are not the equivalent of Robert Goddard versus an Apollo. Again, this was my point. And just to back up again, you know, the no new technology, what it really means is we understand the physics, we understand basic materials. With the physics that we understand and know, and we've turned into engineering solutions, that's where we are. We don't need to create a new material. We don't need to, there's not some fundamental physical process we don't understand that has to be developed or perfected. So, but then going back to the hardware, so the systems that fly on the International Space Station, we all talk about, they're optimized for that mission. And again, they were going, reducing crew time at the expense of mass, because we had a space shuttle at one time flying regularly. And that's a completely different case for long duration life support now. And so that's applied engineering. And again, it's not that there's not hard problems to solve, but that's what people like me and like you guys, that's what engineers are good at, solving problems like that, coming up with simple, efficient solutions. So when you're going to go do this mission, when Bas gets the funding, you're going to establish those requirements. We call them driving requirements in our report, but you're going to go far beyond that. You're going to develop a clean, crisp set of requirements that we designed to, and you'll find that if you build upon what's already been done, you can make those machines operate. You can solve so many problems that we've experienced. Again, I encourage people to look at like the problems that have happened on the International Space Station. Some of them are really simple, and you're like, oh, why didn't we think of that? You know, there's lint that clogs fans, and no one thought to put a filter there. There's dust that accumulates. There's these very simple things that have happened, but we've learned those lessons. And so it's like, in this case, it's like any other industry. You learn from what's gone before. So those lessons can be applied, and you can get to the reliability numbers we need. You can get there. But what you don't want to do is start developing new technology at this point. If Mars One was to go down the path of waiting for the next new technology, again, there's some interesting talks here I heard about today, using the chemistry that exists on Mars now to produce carbohydrates and things like that. You won't get there. You've got to start with what you know.
I'll add one thing, or will I? I just had a thought that I wanted to add, but I think it slipped. It slipped on mine. I'll add it later.
So the topic of this debate is Mars One feasible? And so we presented a set of slides that summarizes what you have stated that you will do, the cost, schedule, scope of doing that. We don't disagree that life support is a solvable challenge, but these projects, they're very complex. It's a house of cards. If any of them don't work, then the whole thing fails. And so we could talk at length about ideas of potential technologies when they might come into play. But you can't assess the feasibility of a program unless you have a concept, unless you have a cost, schedule, scope, and that you've justified for it. And you readily admitted that your concept is still changing. So if your concept is still changing, you still don't know what technologies you're going to allocate your schedule and your funding to develop. So we just haven't seen any arguments to justify that it's feasible. Do you want to add to that?
Yeah, and I guess one thing that's kind of important to note from this panel and from the previous panel as well, and from a lot of other discussion that's gone on, we've seen a lot of excellent arguments for going to Mars, and we have no disagreement with that. That is our goal as well. That's why we're spending all these years in grad school. But to us, that means sort of looking these challenges in the face, saying, what do we need to do? What's kind of the hardest thing here? What are things that we need to be able to solve? And so I guess our question is, we all agree that Mars is a valuable goal. It's where we need to go. And I think we all agree that we'd rather go sooner rather than later. But the question that we're wondering is, why the Mars One plan as it has been presented? And if it's going to change, I mean, the plan as it's currently been presented to us is infeasible, and that was a presentation we made. The question would be, what changes in the cost, what changes in the schedule or the scope of the plan will be made to make it feasible? Because the one that's presented right now, it seems, is not feasible.
And if you're still developing concepts, you don't really have a plan. A plan is you've got your work breakdown structure, you've got your funding allocated, you know what steps are moving towards your goal. So again, the question is Mars One feasible? Can you land 4 people on the surface of Mars, one-way mission, in 12 years for $6 billion?
Did Kennedy have a plan? He didn't have the technology. And look at the slide that I showed you. Everything changed. We are presenting something that is feasible. There's nothing that cannot be done. And I agree with you guys that we are not certain about the cost yet. And I agree with you guys that the cost might be higher. And I certainly agree with you guys that our timeline might slip again. But are we failing if we land humans on Mars in 2030 or 2032? Is Mars One unfeasible if we land in 2032? I don't think so. So one of the important differences between going to the moon or going to deep space and going to Mars is that you can test your systems for a Mars mission with relatively high fidelity here on Earth. So that's why I think our simulation outpost is so important. At first our simulation outpost will be built to test our crews, to see if they can deal with each other basically, and with all the challenges that we will throw at them, but we will start adding the technologies that we want to actually send to Mars, with more and more realism built into them, such that we have pretty good understanding when they do depart, much better than systems that are sent to the ISS, because there is, as we all know, a zero-G environment. So that I think helps Mars One's plan in relatively affordable testing, because we can do it on Earth. So it's an ambitious project, and there's a lot of problems that still need to be solved, but the rockets are not the problem. The transit is obviously not the problem. Landing on Mars, if we have right now the estimate by Paragon is 7.5 metric tons useful payload. If we have to break up that system into two, and 3,750 kilos. I've talked to several experts from NASA. They say that they can do that with the current method. So the heat shield, the parachute, and probably not the sky crane, but retro rockets. The life support system Barry has talked about. I think that suits are actually one of the biggest challenges. So creating a suit that will serve the astronauts for a very prolonged period of time with acceptable repair and acceptable EVA time, because you don't want to spend your life on Mars only inside. So definitely a lot of engineering challenges, but no fundamental things are needed. And our plan is not designed to, for example, you mentioned the rover needs to do all these things. That's not necessarily the case. We might have 2 rovers that do separate tasks, or we might have 3 rovers that do separate tasks. We don't know that yet, but we do know that lifting something is possible. And we do know that moving sand is possible. And we know that. We can test these systems on Earth, because we have a gravity environment, and we can design them, we can build them, we can test them, and we can make them better until they work.
I want to interrupt, okay, because we're about to transition to the next part of this. Which is going to be the questions. Now, this debate has actually attracted some international attention, and we've had some questions sent into us. And in particular, there's been a group of 5 questions sent here from a veteran aerospace engineer from Germany, Jürgen Herholz, who has worked for 3 decades in every European manned space program, from Hermes through the ISS. So he has a number of questions. I just want to ask 2 of them. And they're both directed to Mars 1. The first is, which I think is pertinent, is when does Mars 1 intend to propose a Mars 1 mission, technical and implementation concept in credible detail, taking into account past technical and program experience?
Can you ask him back if he has 15 million? So it's when you start a company. This is the second company that I started. I started a wind energy company. I co-founded it with a technical partner. I was the general manager of that company, and we started looking for investments. And all the time you think that it's just around the corner. You talk to a new investor, you have really good discussions, and for whatever reason it doesn't happen. And that's just a fact of building a company. How many people here in the audience run their own companies? How many are raising money for their companies? So you guys know how difficult it is to raise money for your company. It's difficult. It's unpredictable. You can't control it. And once you have your funding, then you start to actually be able to control things. And at this moment, actually, we do have quite a lot of time. We had to announce a delay in January, but because of how the planets orbit the sun, that actually gives us 2 years to raise the money starting last January. So we do have a reasonable amount of